Welcome back to Chemisode. This is about ionic compounds. It's part 2 of a 2-part series on ionic compounds. The last one looked at the structure of ionic compounds, and now we're going to look at the formulas and names for ionic compounds. Hopefully you've been following along with Chemisode and you've had a look at the other videos that we've done for Unit 1 Chemistry. There's also the app for Unit 1 Chemistry on the App Store. So if you search for Chemisode in the App Store, you'll be able to find that application, which has a whole bunch of these videos and flashcards to go alongside the Chemisode videos that you are currently watching. So this is on ionic compounds, the formulas and the names. Let's have a look at the first part of it, looking at how to write the formulas for ionic compounds. First thing we need to know is about the charges of ions. There are a few different types of ions. There are simple ions. These are just the single element ions. So if they're simple ions, they're usually in the S block or the P block of your periodic table. So they're in the first, second groups, they're in the third up to the 8 groups. So those the normal groups that we're looking at. What we know is the cations are on the left-hand side of the periodic table because they're the metals, and the anions are on the right-hand side of the periodic table. Now we can find the charges for these simple ions by simply looking at the periodic table and finding out the number of electrons in the outside shell and looking at how many electrons these elements will either gain or lose to become stable. Now if we take for example our potassium, which is here, potassium is in the first group. It has 1 electron on the outside shell. To become stable, it will lose this 1 electron and become positive 1. And we just write that as K positive. Sodium, also in group 1, has 1 electron on the outside shell, will lose that electron to become stable, and we write that as Na positive. So just a single positive there like that. These two, both in group 1, both losing 1 electron. Sulfur, on the other hand, it's over in group 6. It has 6 electrons in the outside shell because it's in group 6 of the periodic table. What it will do to become stable is to try and gain 2 to get that magical number of 8. Remember, elements always want 8 electrons to become stable. So because it's got 6 in its outside shell already, it will gain 2 and become 2 negative. That's what sulfur will do. Because it's in group 6, it will gain 2 electrons to become stable and become S2 negative. Fluorine is actually found in group 7. It's a halogen, and it will have 7 electrons in the outside shell. To become stable, to make 8, it will gain 1 electron and become F negative. So it will become that negative charge because it's gained that 1 electron it needed to become stable. Aluminium, on the other hand, you can imagine aluminium is in group 3, so therefore it has 3 electrons on the outside shell. What it does to become stable is it loses those 3, because it's easier to lose 3 than gain 5, so it loses 3 electrons and it becomes Al3 positive. These simple ions, their charge can simply be found from the periodic table, thinking about how many electrons it will either lose or how many it will gain. Your transition metals, on the other hand, which are in the middle, wedged in the middle of your periodic table, these are a bit different. These normally have a Roman numeral next to the name of them. See, copper, because it's a transition metal, it acts a bit differently. It can either lose 1 electron or it can lose 2. It has a bit of a different way it works. We know the charge on these transition metals based around what Roman numeral they have next to them there. So copper 1 will have a positive charge of just 1, whereas copper 2 will have a positive charge of 2. These transition metals can have different oxidation states or different charges. Okay, so that's what these transition metals do, and you find their charge by looking at their little number next to them. The next type of ion we have are called polyatomic ions. And here's a few. This is just a simple table of the polyatomic ions that I found from the internet. And most of the polyatomic ions you're going to deal with are negative. Actually, pretty much all of them are apart from 1. You're going to need to really kind of remember as many of these as you possibly can. The polyatomic ions are not ones that you can easily find the charge of, but there's a few that I'm going to point out here which you really need to know. One of them is nitrate, which is this one here. So these polyatomic ions, just write them down in a little table and memorize them as much as you can. So nitrate is NO3 negative. This one comes up a lot. Nitrate, NO3 negative. Permanganate comes up a fair bit, probably more so in year 11 than, probably more so in year 12 than year 11. So, but permanganate is MnO4 negative. That's the whole ion. They're called polyatomic ions because they have more than one atom that make up that ion. Other ones in the 2 negative charge, you've got sulfate, SO4 2 negative. That's one you're going to need to remember a lot of. So sulfate, you're going to write that one down. And carbonate as well, CO3 2 negative. That's one that really comes up a lot this year and even more so next year. Dichromate comes up a fair bit next year, and that's Cr2 O7 2 negative. It's probably the biggest ion you're going to deal with actually is dichromate. And that comes up a lot next year in year 12. So try and remember that ion as well. The only positive polyatomic ion that we really deal with is called ammonium, and that's NH4 positive. So it just has one positive charge, but the actual ion is NH4 positive, meaning it has 4 H's and 1 nitrogen. And that's the polyatomic ions. Try and remember that your nitrate, which is this guy here, your permanganate, also remember hydroxide actually. Hydroxide is another one that you got to remember, OH negative. So nitrate, hydroxide, permanganate are all your -1 charges. Sulfate, carbonate, and dichromate are all your -2 charges. And then you have ammonium there as well. So they're your polyatomic ions. Remember those because you're going to need to know what their charges are. Now that you understand our ions, we're going to move in and start to look at how we actually write formulas for these ionic compounds. So what we have is writing formulas. I've got a few different compounds here, silver nitrate, magnesium nitrate, sodium sulfate, potassium dichromate. What we're going to do is write the formulas for these, and we're going to need to look at the charges involved in ionic compounds. We'll start off with silver nitrate. When I'm writing a formula, what I first of all do is I try and work out what the charges for these two separate ions are. Silver has a charge of just 1 positive. Nitrate, on the other hand, from our polyatomic ions, has a charge of negative. When we go and make a compound from these two guys, what happens is we want to balance these charges out so it gets to a neutral charge. Now, because we have 1 positive and 1 negative, that will balance out by having 1 of each. So the formula for silver nitrate is simply AgNO3, where we have 1 silver and 1 nitrate together. And that forms AgNO3. The next one we're going to look at is sodium sulfate. Sodium, the charge on sodium is positive, just 1 positive. And sulfate, if you remember from your polyatomic ions, is SO4 2 negative. Now when these guys come together, we want to try and balance out these charges. Alright, so if you want to try and balance this out, you've got sodium is 1 positive, sulfate is 2 negative. It means we need twice as much sodium as we do sulfate. So the formula for sodium sulfate is going to be Na2SO4 because we have 2 sodiums for every 1 sulfate. The reason I've got crossover method written here is because we can do another simpler way of doing this if we want. See the charge on the sulfate here? The sulfate has a charge of 2 negative. What I can do is cross this over, and that's how many of the positive ions I need to balance that out. The sodium is just a 1 positive, and that's how many sulfates I need. So I need 2 sodiums because I got that 2 from the charge on the negative, and I need 1 sulfate because I got that from the charge on the positive, the crossover method. Next one is magnesium nitrate. Now magnesium is in group 2, so it has a positive charge of 2. Nitrate is a polyatomic ion, and it's got a charge of negative. Now using my crossover method, what I'll do is I'll take my 2 from my positive ion, and that's how many negative ions I need. So what I'll do, is I'll give myself MgNO3 and 2 NO3s here, because I need 2 of these to balance out my positive thing here. So you can see the crossover where I kind of take the positive charge, and that's how many negative ions I need. Take the negative charge, which is a 1, and that's how many positive ions I need here. So that's why I only do 1 magnesium, 2 nitrates. Potassium dichromate is potassium's positive. Dichromate is again a polyatomic ion, and that's Cr2O7 2 negative. Using my crossover method again, I'll take my negative charge here. That's how many positive ions I need. So it'll be K2, and then however many positive I have is how many negative ions I need. I've only got 1 positive here from the K. That's how many of these dichromates I need. So therefore, I've got K2 Cr2O7, because I need 1 of these dichromates and I need 2 of these potassiums. You can think about this and think about just how you're going to balance these charges out if you want, but that's just the crossover method is a simple way of where you just take the however negative you have, that's how many positive ions you need. Now, these ones are for you to have a crack at: lead nitrate or lead 2 nitrate, calcium carbonate, silver chloride, potassium fluoride. Pause this podcast, have a go at trying to write down what the formulas for these you think are. So first of all, write down what the charges on the ions are, and then work out what the formula is going to be. So pause this for 2 seconds, and then play it and see if you got it right. Now let's see if you got that right. Here are the actual formulas. So the only one that we really have an interest in is lead 2 nitrate. Lead is a 2+ because it's got the Roman numeral 2 there. Nitrate, as you know, is a negative, so therefore you need 2 nitrates for every 1 lead. Check your answers. If you're not happy, send me an email and I'll try and help you out with your writing your formulas for ionic compounds. Let's move on and let's look at how we name ionic compounds now. We name them by first of all writing the cation, and then afterwards we write the anion. So first of all, let's look at potassium over here. The cation is always listed first, and that's our potassium. Our anion is listed afterwards, which is hydroxide. So this one is potassium hydroxide, simply because we write the cation first and then the anion. In this one, we have calcium as being the cation. The anion again is hydroxide, so it's calcium hydroxide. This one, this ionic compound here, is ammonium, which is our positive ion, which is the only positive polyatomic ion, ammonium. And then our anion here is sulfate, so it's ammonium sulfate. First of all, list the cation and then list the anion. If you have a simple anion thing from the periodic table, you change the end of it to "ide." So if you have an oxygen as your anion, you change it to oxide. If you have a chlorine as your anion, you change it to chloride. I don't think I have any examples. Oh, I have an example here where I have this guy, potassium, and I have chlorine as my end one. This becomes potassium chloride because I changed the anion to an "ide" at the end. Magnesium hydroxide over here because I have magnesium and the hydroxide ion. And here we have ammonium nitrate because we're just simply listing the cation and then the anion. It's really simple with your ionic compounds when we're naming them. It's simply just the cation and then the anion. Moving on, and let's look at how we deduce a charge. If we want on these ones here, this is a bit of thinking about it. We have, what is the charge on X? So what charge do you think X will have in this ionic compound? Now, if we want to think a charge, we need to think about what charge is there already. Sodium is Na positive. So that means that X here must balance out that positive by itself. So X must be negative, first of all, and to balance this positive out, it must be X negative, just by itself, because you need 1 positive need one negative, so X must be negative. In the next one here, XCl2, deduce the charge. Chlorine, or chloride, as it will be in an ionic compound, will have a negative charge. That means X must be positive. How many positive must X be? You need 2 of these chlorines to balance out 1 of these X's. So therefore X must have a charge of positive 2. Next of all, we have our hydroxide, X hydroxide. Hydroxide is negative, so therefore X must be positive. How many positive must it be? It must be enough for one of them to balance out this negative here, so therefore it has to be positive. Pretty simple like that. Just thinking about how can we balance out these charges. Here, oxygen is 2 negative. Okay, we can think about reverse crossover. Take this 2, that's what the charge on the anion must have been. So therefore the charge on the cation must be this 3 here where it comes up. So X here is 3 positive. Just thinking about how this must balance out, we need 3 2 negatives. That makes 6 negative. That must mean each of these, each X must be 3 positive because we need 2 of those, which will make 6 positive as well. So overall, we have 6 negative on the oxygen and 6 positive on the X, because that's how the total charge on each of these positive and negatives we have here. Hopefully that makes a bit of sense to you, how we can find the charge of an unknown ion by looking at what must balance out in our compounds. Now, a bit of a summary, what you should be able to do. What you should be able to do for ionic compounds is list the properties of ionic compounds. Simply state what they are. You should be able to explain the properties of ionic compounds. So explain why ionic compounds have the properties you've listed there. You should explain them in terms of the ionic bonding model from part 1 of this video. You should be able to draw electron transfer diagrams for ionic compounds, also explained in part 1 of the video. Alright, I might do another video on drawing electron transfer diagrams as well, for fun, basically, just so you know how to do those, because they do come up in exams a little bit. And also, number 4, you must be able to write formulas and name ionic compounds. Okay, so 3 and 4 can kind of help you out a bit. If you can draw electron transfer diagrams for an ionic compound, you can probably work out what their formula is going to be as well. But write the formulas, think about the crossover method for that. And that's your summary on ionic compounds. And hopefully this video will be probably not too long. Hopefully it's within about 15 minutes. And next time we'll look at covalent compounds. So I look forward to talking to you then about covalent compounds.